All right, I'm going to hit record. All right, there we go. Okay, well, let's, I'm going to go ahead and just share my screen here. And I put together a couple, just a real quick spreadsheet just to walk us through what it's like to plot in Excel. And I'm just going to do the very, very, very basics. I'm not going to do anything fancy or make any kind of fancy charts, because I'm not expecting you all to do anything fancy. If you want to do fancy stuff, go for it. But I don't want to overwhelm us with this assignment or anything like that. So here is a data set where we have, and Allison, can you hear me okay? I know my babies are being kind of loud. Can you hear me okay, Allison?
I can. I hear you fine.
Okay, perfect. All right, thank you. Thank you for being my bellwether. Here in this is a data set that is showing lake level amounts in Michigan. So there's 4 lakes, dates, and then I just put in this column of points. A thing that you can do in Excel if you don't know, for instance, if you're in a contiguous data set like this one, you can say, put in like 3 numbers like this, highlight it, and then here on the very bottom right hand corner is that little square. If you just double click on that square, it'll automatically populate it for the entire data set. So that's just an Excel shortcut. That's how I, just to have. But what I did here is I just wanted to do a very easy chart first. So I just took 10 data points. This data set goes all the way back to 1990 to 2021, but I wanted to just do just 10 data points, okay? So I'm going to highlight the way that you want to do your chart in Excel is that you want your x-axis be on the left of the column and your y-axis be on the right. Okay, and then you can highlight your data set and go to insert, and here where there's charts, usually the best type of chart for you looking at climate trends is going to be a simple scatter plot. And you can see that there's different scatter plots with these different lines going through them. Those are a little misleading. What you want to do is just see the data scattered. And you can see that because I had y-axis, because I had the y-axis highlighted, it went ahead and labeled it for me. So if I wanted to say, instead of y-axis, if I wanted to say lake level, so you can see that it changed in my chart in real time. So let me just get rid of that one. So here, this is just a real simple figure. But in order to see whether or not there's a trend, come over here to this plus and add a trend line. What you can do is, you might have a different version of Excel. You can also usually right click. Yep, you can. If you put your mouse over the data point and hit right click, you can also add a trend line that way. And that works in earlier versions of Excel. So this is not a real data because it's only 10 data points. So I wouldn't trust this as evidence of climate change. But I just wanted to have a very simple chart just to explain how you would go about interpreting this chart. With the trend line that we added has a negative slope, meaning it's decreasing as we go farther up the x-axis. It's decreasing. If it were increasing, it would look like this in the other direction. So increasing, decreasing. And if it's decreasing, that's showing you the trend over time. So you can say that if these were real data that you could interpret, you could say something like the lake level is decreasing over time. If it were the other direction, you could say the lake level is increasing over time. Yeah, so you can even add like I added access titles. something like that. So that could be your chart that you could turn in for your assignment. But let's look at an example here that's a little bit more realistic. These are precipitation data for my region here in Louisiana. And so we have like January, February, March, April, May. Here's the months. And then and this last column is for annual. But let's just take, for instance, this goes all the way back from 1900. Sorry, babies. This goes all the way back from 1900 to 2021. So it's a really complete data set. And I have some missing data that show up in here as M's. That's going to throw off Excel. Excel doesn't know what to do with M's. So what I did is I just deleted those M's from 1900, 1901, and 1902. And here was some more M's in 1913 and 1914. Again, 1922 and 1923. Those are just years that they don't have data. And that's very, very common in these kind of long-term data sets. There's just some years where the data weren't able to be collected. So I just deleted them and left them blank. So I'm going to highlight this with my mouse. Again, the date is in the left-hand side, and that's going to be my x-axis, or the year is going to be the x-axis. And then the y-axis is going to be this precipitation. Okay, so I'm going to come back to insert charts, go to scatter, and here is here's the chart here. So if I can make it bigger, and here's my my chart title could be January precipitation versus since you could say 1900 to 2021, something like that. Okay, and then if we want to go to axis titles, we could say this is January precip, and this can be here, something like that. And then the important thing, remember, is either to right click on the data and add a trend line, or to come here and say add a trend line. You can see here, because of this trend line has an increasing slope, that you can say that the data are increasing. If you wanted to get fancy, you can add a trend line. Let's see, let's go back to that. You can add an exponential, logarithmic, linear, polynomial, power, moving averages. Those are just shapes of the curve. Those are just shapes of lines. We're going to do linear. And you can even display the R square value on your chart. You can display the equation on your chart. This is actually how you do modeling. When you're doing modeling, you're saying, okay, here's the equation of this line. So we could extend that line coming out to 2040, and we could model what we think these values, these missing values, or these future values could be based on this equation. So that's how you do future modeling. You take your historical data and you find the line, and then you take that forward. And also you can, for instance, maybe the linear line is not the best fit. You could also do an exponential line, or you find the line that has the highest R square value, and that's what you use. That's beyond this course. That was just a little tidbit. So if that's hurting your brain, don't worry about it. I'm going to delete it and get it out of there. This is what you would turn in for your assignment this week. And you would then in your narrative say, I can see due to the increasing slope, or the positive slope, that precipitation in January has increased from 1900 to 2021. Does that make sense, Allison?
Yeah, that's super helpful. Thank you.
You're welcome. And yeah, so you just got to play with it a little bit. And then, so most of you will be doing the scatter plot like this, but if you were to do a simple bar chart, here's another little data set. This is just looking at rainfall in 2021. So, I just pulled a data set out of like a random data set, looking at June, July, and August. But let's say, for instance, let's just change this, and let's say that this is for 1990. Whoops. This is for 2000, and this is for 2010. So let's give it like a time series. what you're going to do is you're going to select the entire area of this. If you want to do a bar chart, go back to insert and come to bar. So if you want to do a 2D column, you can look at it like this. And for some reason, this is plotting. Oh, I see what it's doing. Let me just change that. It was taking that as data and not just the heading. So you can do 3D, you can do sideways, you can really play with it. But let's just do a simple chart like this. And you could say, you can add a trend line to series 1, which is the blue. You can add a trend line to series 2, which would be the orange. You can see that there's series 1, series 2, series 3, if you would like to look at it in that way. So it just really depends. Again, you can add axis titles. So you can say, precipitation. And if you're really doing this the way that you should in science, you would put the units, so precipitation in millimeters. And then you could title this one down here as the city. And then you could say, something like that. Yeah, of course I just made that up. But that would be a way to do the charts. And so when you go to insert and you go to charts, there's all sorts of charts here that you can make. You can do a pie chart, which I didn't highlight any data. So you can just kind of play around and see, what kind of chart would best describe your data. So make it, you can make a couple types and then say like, okay, I'm trying to tell a story. Which type of chart would help me best to tell my story? And for most data sets, it'll be just this plain old scatter plot. It's not as interesting. You can change the colors here in Excel. There's a lot of different features that you can do to make it look the way that you want to look, changing the colors. There's a lot of ways to customize that. So that's all I had planned to show you guys, but if there's any questions while you're working on your assignment, just reach out and let me know. And Allison, do you have any questions while we're online?
Not that you haven't already addressed. This looks great.
Okay, cool. Well, why don't you get to playing with it? The key for this assignment is making sure that one, you have access to the raw data. So a lot of the data sets that you find on some of these sites are already the charts or the graphs or the maps. And that means like you're seeing someone else's, you're not seeing the raw data, you're seeing someone else's interpretation or someone else's visualization. And that's not a bad thing, but this assignment, we are practicing making our own graphs. It's good to just play a little bit with data. Like we want to have a little bit of that quantitative experience coming out of this course. So this course isn't super quantitative. This is about as quantitative as we get, but it is good to have that experience to be able to do it. If you get a job after this program and someone says, hey, make a chart for da-da-da-da, we want you to be able to say, oh yeah, I can do that. I can just jump on and make a chart real quick in Excel. And so the one thing is to have access to the data. And the other thing is, in order to make really, statements about climate change, you want to have long-term data sets. So multiple decades is desired. Sometimes, depending on the data set, it could go back thousands of years, sometimes even millions of years. Like if you're looking at ice cores or the fossil record, awesome. The farther back in time, the better you can actually say something, because with climate, as you're learning in the lectures, there's a lot of variability due to Earth systems and like Pacific Decadal Oscillation, El Nino and La Nina. There's a lot of reasons why in a single decade, like if say your data set only goes back to 2000, there's a lot of reasons why you might see an increasing or a decreasing trend that has nothing to do with climate change. But if you can go back to 1900 and show a pretty good average, there's going to be a lot of mess. So you remember on that chart, that scatter chart, there were a lot of data points all over the place. That's called variability. And that's very typical of climate data, because there's so many reasons why the data are the way they are. It could be the Earth sea level rise or sea surface temperature. It could be, a lot of different things going into the pattern of climate. But over time, you will see that trend line shifting. And that's what we're looking for. The longer the data set, the more confidence we can say that trend is significant. So if you only have a couple decades or even 10 years or 5 years in your data sets for this assignment, that's fine. Go ahead and plot it. But in your discussion and the narrative, talk about that limitation.
Okay. That's perfect.
Okay.
Thank you so much. We'll get to plotting.
Okay. Yes. Plot away.
Thank you.
We'll see you soon.